So let us start today's session with reviewing the last class concepts. So in the last class we introduced the AC introduced the AC, that is alternating current, in which the major characteristics are that the amplitude the amplitude and, or maybe both things, amplitude and the polarity, let me say as polarity. So these one or both together may change may change, as because there is a change in the things, and certain patterns, certain change going to be repeated for every certain interval of time. So that repetitive nature we called as a periodic waveforms. Periodic waveforms. That the nature of the waveform which repeats for every certain interval of time is known as a periodic waveform, and that certain interval of time, certain interval of time, certain interval of time at which the pattern is repeated is known as time period, which is very important. Time period we usually represent by the capital letter T. And one more important word we introduced, which is frequency, which is frequency. So usually represented by the small case letter F. So if we see the number of repetitions which taking place in 1 second is called as a frequency. So those repetitions we technically call as cycles. The number of cycles per second will be referred as a frequency, which is equal to simply what reciprocal of the time period. And apart from this, we also see some more important thing, that the sinusoidal, out of various kind of AC waveforms, the sinusoidal waveform is of very interesting due to certain characteristics that we come to know little later. Sinusoidal waveform, sinusoidal waveform, and how these sinusoidal waveforms will be generated. Sorry, I'm repeating twice. How these sinusoidal waveforms will be generated, that I had shown you. If we make there is any relative velocity between the conductor and the magnetic field. So we need two things, one is conductor, other is magnetic field. If there is any relative velocity between them, it produces the induced EMF, which can be represented as E of t, or which can also be said as the voltage, which is equal to something like BLV sine omega t, omega t. So in more generalized form, we had written this as Vm sine omega t plus 0 degree. And the generalized way of the voltage representation, sinusoidal voltage representation, will come in this form as Vm sine omega t plus or minus theta. Theta can be 0, positive or negative, any value. So this is what the sinusoidal voltage, and whose peak value is Vm, angular frequency is omega, and this omega can be represented as 2 pi f in terms of frequency, or 2 pi by t in terms of time period of this waveform. And this theta represents the amount of the shifting of the waveform, whether it is shifting like towards the left side or towards the right side. That we stated in the last session, that advancement 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 or delay advancement or delay, If it is delay, it represents lagging. If it is advancement, it represents leading. These are the terminology which we introduced in the last session. And once again refer back those waveforms and try to get the clear idea about these leading and lagging concept. Okay. So now let us see one more important features about this AC is that try to observe that first thing about the DC systems or DC voltage, let us say voltage DC voltage. For example, if I'll draw some waveform in this way as like this, let us say this is 10 volts which is starting at 0 and continuing to up to infinite like this. Now if somebody asked you that at 5 seconds how much is the voltage, or at 10 seconds how much is the voltage, or at 100 seconds how much is the voltage, what you could say blindly is that we have 10 volts. We have 10 volts. And we know that what does this voltage will do? This voltage will do that it will try to transfer the charge from one location to another location. It is the electromotive force which pumps the charge, which transfers the charge from one point to another point. Then how much is the amount of the charge transfer that relevant to the work done? So that we had seen, so that we don't want to go into the depth of that, just try to think that what does this voltage will do. Okay. Now if we see these periodic waveforms, periodic waveforms, what are the main characteristics of these periodic waveforms? One is amplitude and the directions are changing continuously and a certain pattern going to be repeated for every certain interval of time. These are the important characteristics about these periodic waveforms. So amplitude is continuously changing. Now, how could I say that? How much is my voltage in case of the periodic waveform? As like in the DC system, I could say at 5 seconds or at 10 seconds or at 100 seconds, I can say that it is having 10 volts strength, which is electromotive force, so that it is transferring certain amount of the charge. But how could I say when it is continuously changing? So there is no direct value of the voltage for this periodic waveform. So what we come across to deal this situation is that, so try to see that if I'll put these things, if I'll put these things to a circuit, let us say this is a circuit. This box is a circuit. This box is a circuit. Now for this circuit, what is the input? DC voltage source. Clear? What does it do? It will try to pump the charge Q. Let us say, so the plus Q in this way, plus Q, etc. The charge is transferred into the circuit. The charge is transferred into the circuit. Now, let me take some periodic waveform. So that may be, let us say, some uh, any kind of waveform. Let us say some.
వచ్చేస్తారాళ్ళు మరి మధ్యాహ్నం గట్ట పాటు చేసేస్తే
Right. So if we have this kind of voltage waveform, try to observe the amplitude is changing and its polarity also changing. This is positive half cycle, this is negative half cycle. Putting together up to this place is what the time period for which the waveform going to be repeated. So this nature is repeating again, that this is positive half cycle, this is negative half cycle. Again same thing is repeating, positive, negative. And of course these all are similar in nature, just like twins. Okay. So a copy is repeated. That is what the repetitive nature we called as a periodic waveform. Now observe that amplitude is continuously changing. What shall I say about this charge transferring, that which is transferring from the source to the circuit? If I'll connect this AC voltage, let me say that here, so I have some voltage source and I am trying to represent that with certain circle symbol in which the voltage value is V, and this voltage V nature is represented over here. So previously this was a constant, so I had represented just like battery. So but here I am not representing anything as of now. So what I am saying is that this voltage nature is as like this, left side. Now, so how could I check that this AC wave nature with the DC is that how much this AC wave is transferring the charge from this source to the circuit. That is the comparative, the uh, point which we would like to take up in the further discussion. That so we would like to see if this source also contribute same amount of the charge as like the DC source, some value, that may be some equivalent value. So let us see, as the voltage increases, what happens? Its charge transfer rate capacity going to be increased. Okay. Then suddenly it is dropping down to zero, negative. Then a negative voltage is applied. That means the charge transfer rate going to take place from circuit to source. Why? Because voltage polarity has changed. Okay. Next is that then again a positive voltage pulse is applied. Then charge transfer rate will take from voltage source to circuit like this. So ultimately, over a time, over a certain time period, let me say that over a certain time period, over a certain time time over a certain period or time period, how much is how much is the effect of AC in comparison with in comparison with DC DC. So this is our major important discussion point, that over a certain period of time, how much will be the effect of the AC in comparison with the DC. That comparison we will try to do in two specific values. One is average value. One is average value. First we see how to calculate these values for the given AC waveforms. Then later we think of that what will be the relation, or what will be those corresponding values which justify this statement, that over a certain time period how much is the effect of AC in comparison with the DC. So that effect, that comparison is done in terms of these values. One is average value, one more I will try to introduce as RMS value. So now let us take the average value and let us see how do we calculate average value. And this, if I'll have a generalized function f of t, this may be voltage v of t, or it may be current I of t. So what will be the nature of v of t and I of t is, previously we seen some waveforms such a nature. Now, so mathematically, we can say that FAVG means average value of this function f of t is equal to integral over certain interval of time. What is that interval of time? Is that 0 to 1 time period. 0 to 1 time period. So integrate the corresponding function f of t with respect to time dt and divide this entire value with one time period. With one time period. So this is what the average value of any function f of t mathematically, and what does this represents is that, let me elaborate this expression. Usually try to observe that integral of any function will gives area under the function. So I can say this as area area under area under given 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 function given function f of t, area under the given function f of t. So area under the given function f of t is represented by this integral, then divided by the time period time period time period over which this function has spread. Usually, what is the time period here is that, just let me show the above waveform, that see here, here is the time period. Means this function v is spread over this distance of time. This distance of time. So now just try to understand that mathematically we can write average value as integral of the function divided with time period. And try to observe that integration limit duration and this division of the time duration both are same. See that how much is the integration limit duration? Distance is t minus 0 is equal to t, which is same as that of this t. See here, division, whatever we are dividing, this entire area of the given function f of t is the time period. How much is this time period? Is integration limit, whatever may be the limit. Here if I'll say 1 to 10 seconds, then here I will get 1 by 9, that is 10 minus 1. Okay, like that. Okay. So now let us take some waveforms that what we had seen in the last session and try to calculate the average value for different waveforms. Okay. So first let me take uh, some waveform in this way. So here, sorry. Right. So it is a periodic waveform. It will continue and so on. Okay. And this is a time axis t. Let me represent certain values for this. This function I am considering as a voltage function and whose positive peak value is, let us say, 7 volts, whereas negative peak value is lesser than the positive peak value, so which is minus 5. And the time limits are in this way. This is 1, 2, 3, 4 and so on. Okay. So now tell me, for this waveform, for this given waveform, so sorry, for this given waveform, so how to find the average value, for which what I should find is that what will be the function. First of all, what will be the function? Voltage function. Then how can I write this voltage function mathematically? Mathematically, how can I write this voltage function? That you need to think. That is one thing. Once I know how to put this v of t in some mathematical form, so we all know that how to do the integration for that mathematical function, that this part is completed. What else we need is that what will be the time period t. So could you identify here certain pattern going to be repeated for every certain interval of time? What is that duration of the time? Can you identify the duration of the time? So try to observe 0 to 1 second, it remains constant at 7. At 1 second suddenly it dropped down to minus 5. And it remains constant at minus 5 for next 1 second. By the time 2 seconds, then it reached back to 7. Now hereafter try to observe. Again, for next 1 second, the same pattern is going to be repeated which happened in the case of first positive half cycle. And after 1 second, that means this amount of the duration, again it jumped down to minus 5. That means that same thing happened at 1 second. And it remains stay at minus 5 volts for one more 1 second. So this is what this negative cycle repetition. So in this way you can observe that what will be the duration of the time for which the waveform is repeating again and again. So if you want more specifically you can make some kind of thing in this way that here I have one positive and here I have one negative. Both are not similar in nature. So this is just like some rectangle box. This is also some rectangle box but area is different. And next same box is going to be repeated as like the previous green color box. And same kind of box one more times going to be repeated as like the blue color. So these green and blue color box going to be repeated further again and again. Then for how much duration of time this pattern green and blue color box is occupied, that duration of the time we call it as time period. How much is that? 2 seconds. Let us say time is in seconds. Clear? Right. So now let us think of, we got the time period. So what we need additionally is that how can I express this voltage function in mathematically? So see that in this way, just think. So as like this, so you have a line, whose starting point that coordinates are the x corresponding coordinate is 0 means it is at 0 corresponding position. The y corresponding position is at 7 where 0 represents that is what x-axis. X-axis is equivalent to time axis here as because it is first time I am representing this as x-axis. X-axis is replaced with time means at this instant, so let me put some major point that this is A, this is B. So what is the point A is 0 comma 7. What about the point B? Point B? Point B represents x corresponding coordinate is 1, y corresponding coordinate is 7. Now, can you find this corresponding line equation? We have a line with 2 points. So, can we find the line equation? So, what is the line equation usually? This, if I'll consider x1, y1, if this is x2, y2, so y minus y1 is equal to slope m into x minus x1. So try to observe, y means voltage, x means time, x1, y1 means these values. Okay. So now tell me how much will be this corresponding equation, line equation. So what does it represent? Tell me. Y means, what is Y here? V of t. Check it. What is Y1? 7. What is the slope? Y2 minus Y1 by X2 minus X1. Y2 minus Y1 is 0. So, slope is 0. Into anything will be 0. So, I am leaving that. So, simply V of t is equal to 7. Now, try to observe, did I got mathematical expression for my waveform, voltage waveform as like this? But try to observe carefully that how long this is valid. How long this is valid. For what time interval this is valid. This is valid for 0 to 1 second. Now at 1 second what has happened? Suddenly the voltage has dropped down to another point. Let me say the corresponding point is C. And one more point is D. Now let us check again this corresponding line equation which is a CD. CD. For CD, tell me now what are the its corresponding coordinates where C is existing? What is its x corresponding point? 1. Y corresponding point? Minus 5.
Minus
So 1 comma minus 5. What about D? 2 comma
2 comma minus 5.
minus 5. So now find again this line equation. As because the slope is again just sleeping line, horizontal line. So I can directly say that, so V of t is equal to minus 5. If you want, you cross verify as like in this above case. So how long this is valid? It is valid from 1 to 2 seconds. So what is our time period? 2 seconds. Now do we got the mathematical expression for this voltage for this entire duration 1 to 2 seconds? Yes, we got. See here, 0 to 1 is this one, 1 to 2 is this one. Now what I will do is that directly I will evaluate V average as 1 by t integral over 0 to t V of t dt. Now try to observe here the very interesting point. So over this entire interval of time, I don't have one single function f of t. Sorry, that f of t means v of t. Here I have two v of t's. One is for 0 to 1 second, another is 1 to 2 second. What I will do is that simply I will try to split this integration as integral over 0 to 1 v of t dt plus 1 to 2 v of t dt. Now I know what is v of t for 0 to 1. What is v of t for 1 to 2. So I can easily evaluate this integration. Now how much is t? 2 seconds. So 1 by 2 into integral over 0 to 1. What is v of t for 0 to 1? 7
7.
dt plus 1 to 2. What is v of t? Minus 5 into dt. Now evaluate this integration and tell me how much is the value. So 1 by 2 into 7 into t. Integration limits are over 0 to 1. So 1 minus 0. That is what? 7. So minus 5 into, so 2 minus 1. That is 1. So how much is this? 7 minus 5 is 2 and divided by 2 is 1. So average voltage is 1 volt. Average voltage is 1 volt. Am I correct this? Just check it. If there is any mistake, let me know. Is this clear? Right. So let me show one more important thing also as like this. See here. As I told you that area under the given function f of t divided by time period also gives the average value instead of this integration and etc. Now if we know the shape is well defined as like this, we said that we have this kind of shape now. So sorry, it is a bad thing. As like this kind of shape we have. So try to observe what are these corresponding things. Height is 7. How much is the width? 1 second. Height is 7 volts. So it look like rectangle. Do we know the area of the rectangle? How much is the area of this rectangle? Tell me. Area of the rectangle. Then
7, sir.
for other side, also we will have, am I used pink color? No, blue color. So let me use uh, blue color. For the next 1 to 2 seconds also, this is 1 to 2, and sorry, I should represent at the at this location 1 to 2, and this height is from 0 to -5. Means how much is this height? Simply 5. Though it is negative, but it is my 5 of height. Units are 5. So how much is this distance? Width 1. 2 minus 1. So again, how much is this area? So previously it is 0 to 1. So this is length into breadth. 7 into 1 is equal to 7. This is 5 into 1, again it is equal to 5. But try to observe, this is negative. This is, let me write, this is negative cycle. This is what? Positive cycle. Now putting together, how much is the total area? Total area, total area is equal to 7, that is positive area, minus 5, which is negative area, is equal to 2. So total area divided by, now let me say average value, you will get directly. See that area divided by time period t. How much we will get? 2 divided by 2 is equal to 1. This is what? Average value. Am I getting same value or not? So all the times this kind of area calculation is not possible, as because we know only for limited shapes the area formula. If it is a triangle, we know the formula. If it is some rectangle or square, we know the formula. But if it is some undefined shape, something like this, so it is difficult to find the area directly by using any formula. Instead of that, we will find its corresponding equation and we will integrate so that we will get the area. So usually I prefer this kind of method instead of just finding the area. But in competitive exams, if it is of a simple this kind of wave shape, You can directly go with the area method. You no need to make integration and all those things. Directly you can find how much is this area, how much is this area. As because this is positive and this is negative, you subtract it, divide with this entire period. You will get the average value.